Good day, everyone. Let's continue the discussion of sample size. This time we'll be discussing another formula that can be utilized to determine the minimum number of sample respondents in a given situation. And this one is a Cochran sample size formula, which was introduced in 1963. And this formula class can be used for infinite population. This is the Cochran sample size formula, N sub O, is equal to z squared times p times q over E squared Z. This one class, the Z is the critical value of the desired confidence level. So in every situation, there must be a given confidence level for us to determine the value of Z. Then we have A is the margin of error. We'll just square that value. Then P is the estimated proportion of an attribute that is present in the population. And how to solve for Q class, we just simply one less P. Let's have an example. Now, suppose we wish to evaluate a statewide agricultural extension program in which farmers were encouraged to adapt a new farming technology. So in this case, class, we can assume that there is a large population, but we do not know the variability in the proportion that will adapt the new farming technology. Therefore, class, we can assume a P equals to 0.5 and suppose that we desire a 95% confidence level and the margin of error class is 5%. So using the Cochran sample size formula, we have here the critical values, the Z values given the confidence levels. I'll just provide class the corresponding Z values given the confidence level. In our example, the confidence level was 95%. Therefore, the Z value is 1.96. We'll just substitute this one in the formula class. And in our example, P is the estimated proportion is 0.5 and the margin of error is 5%, which is 0.05. So what would be the value of Q? The value of Q class is 1 minus P. Our P is 0.5, therefore Q is 0.5. So our Z, as I mentioned, it's 1.96 because the confidence level is 95% class. Again, it's just a matter of substituting all the values in the formula. The Z value class is 1.96, this one raised to the power of 2, and the value of P is 0.5, and the value of Q is 0.5. So we will multiply this 0.5 times 0.5, then the product multiplied by the square of 1.96. Then the answer of this, you divide by the answer of the denominator 0.05 raised to the power of 2. So the answer is 384.16 class. Now, in the determination of the sample size, regardless of the decimal value, automatically class round to the next whole number. So the minimum number of sample respondents is 385. So we will not apply the rules in rounding off here. So regardless of the decimal value, you have to round this to the next whole number. Now let's have another example. Assuming you chose a 90% confidence level, 0.6 standard deviation, and a margin of error or the confidence interval of plus minus 4%. So we have here the 90% confidence level. We will check now the Z value. So the Z value, let's go back to this one. The Z value is 1.645. So we will use that in determining the sample size of the given problem. So we have here 1.645. Go back to the formula. This will be 1.645 u squared. Our P in the problem class is 0.6. So we'll use 0.6 here. This one is 1.645, then 0.6. Q is 0.4 because 1 minus 0.6 is 0.4. Then the margin of error is plus minus 4%. So it will be 0.04 u squared at 1. Then just use your calculator class. The answer is 405.9, or that will be rounded to the next whole number. That's 406 respondents is needed to a 90% confidence level, 0.6 standard deviation, and the confidence interval is plus minus 4%, which is 0.04. That's it for the Cochran sample size formula.